Hi, I am Vivek Kumar. I have over 12 years of experience in the tech industry. I worked as software engineer and in some other roles, and I've decided to share my knowledge about solving coding questions, which is one of the most important steps in the recruitment process of these companies. So if you're looking to look forward to building your logic to solve the coding questions, you have come to the right place. And I'm going to teach you in a easy way, which you can remember the basic steps, and those basic steps will lead you to the answer. So in this particular course, I'm going to focus on binary tree and the questions which can come on the binary tree. Now I will be preparing some other topics in next of the courses related to knapsack, longest common subsequence, and those questions, and some other array manipulations and matrix rotations, and there are many other topics related to linked list and others, which I will be covering in the next parts of part 2, part 3 of this series. So in this particular course on binary tree, I'm covering questions such as finding the lowest common ancestor, finding distance between two nodes in a binary tree, tree traversals, depth first search, breadth first search, then binary search tree, how to find LCA in a binary search tree, binary search, then binary search in a nearly sorted array, not fully sorted, and balanced brackets. These are the questions I'm going to cover in this course. So let's start with finding the question, finding lowest common ancestor in a binary tree. This question. These are quite handpicked questions I have handed for you based on my experience with the companies in the software industry, on my experience over the past 12 years. So when it comes to a binary tree and we have to find our lowest common ancestor, what we can really do in a binary tree. So binary tree is something, the kind of structure which you can see on the left side here. So let me focus here. So on this particular left side of the screen, you are seeing a binary tree. It has the root node as 10. The root node 10 has two children, node 20 and 50, and so on. Like node 20 has further children as 30 and 40, and 50 has 60 as its child. So what are the basic operations which you can do on a node in a binary tree? One operation you can think about is as looking up the value of that node. Let's say I'm at the root node 10. So I can just check the value of root node 10, whether this is the value which we are looking for, right? That's one of the operation. The other operation is you can traverse the child nodes of the node which you are currently at. So I can go to the left subtree, left child of node 20 and right child of node 50, right? So these are the three basic operations. And based on these three operations, we can solve all the problems in a binary tree, right? So let's look at some of the examples here. Let's say we are looking for finding the LCA of node 30 and node 40. So the LCA is node 20 here, and we are going to find some easy logic which we can use to get the answer, to find the answer of LCA. Second example is considering node 30 and node 50. So the LCA of these two nodes will be 10. The node 10 is the LCA because one node is present on the left subtree, the other node is present on the right subtree. Now, another special case is what if one of the node is child of the other node for which we are looking for. Let's say we are looking for node 50 and 60. We want to find the LCA of these two. So the LCA of 50 and 60 is 50. So it is not necessary that some other node all the time will have to be the value. It's not that node 10 will have to be the LCA. Node 50 itself can be the LCA if the other node is present under it, right? So these are the some of the examples. So let's look into them and try to drive a logic which we can use all the question. So there are two basic common points which you can remember and which are logical to remember, easy to remember, which will lead you to the answer. One is if you are at any node, let's say we want to find the LCA of 20 and 50, and you are standing at root node 10, starting here. So as you traverse this tree and you compare the current node's value, you will find that one side will return 20 as the answer, the other side will return 50 as the answer. And so node 10 will have answers coming from both of these children's from both sides. So when both sides are returning true or the values, then you return the current node's value as the LCA, right? So this is what I'm trying to say here. Where a node has found both descendants for which you are looking for, then it returns itself. So node 10 will return itself as the LCA in this case. So, and the other easy logic is, and very reasonable logic is, if you have a value coming from one side and null coming from the other side, let's say we are looking for node 30 and node 50, right? We are currently at node 20 and during the traversal process, and we are trying to find the LCA of 30 and 50. So 30 at this place will return one of the answer as 30. From the other child of 20, it will return null. So when you have value coming from one side, you return that value. You do not return itself. You do not return 20's value. You do not return null value. You return the value which you are getting, you are finding here. So that is the second logic. And these two, if you apply it correctly, it will lead you to the LCA. So let's see here. So during the traversal process, what will happen is the recursive algorithm is based on the stack process. So as you call the function itself, it it stores the call on a stack, and that stack is called back when the control returns back when the uh, node children functions of that particular function returns, then the control comes back. And so what will happen here is, so if you are thinking about the time complexity at this point, so you can very well be rest assured that the time complexity is O of n, because the control goes exactly once at each node, not more than that. And so O of n is the time complexity here. So when we are looking at the example of finding LCA of node 30 and 40, so what we see is the control goes from node 10 to node 20, from node 20 to node 30, and at this point one value is found. That value is returned to the parent. Now it has the node 20 is getting value from one side. It looks into the right child, so right child, again it founds in next node 2 value, and 40 is returned. So now node 20 is getting value from both sides. So it returns itself as the LCA, right? So this is the first easy logic which we were discussing here. Now what happens is left subtree has been traversed. The control goes to the right subtree, and null is returned from the right subtree because 30 and 40 are already found here. There is nothing from node 50 and 60 that will match, so it will return as null. So our second logic applies here, and 20 is returned as the LCA because node 10 has value coming from one side and null from the other, so it returns the value which is coming from one of the side. 20 is LCA here. So let's look at another example of 30 and 50. So as the control goes to the left subtree, it finds the value 30 is returned, then 40 does not match 50-50, so null is returned. So in this case, 30 is returned from this particular node parent of 20. 30 is returned since value is coming from one side only. Then control goes to the right side, and 50 is returned from the right side. And so the node 10 sees that value is coming from both of its sides, so it returns itself as the LCA. That was the first logic which we discussed earlier, right? So the deriving the logic from that particular to those 2 points is, if you arrive at a node which is null, you just return null, right? You don't further traverse the tree. Like in this case, we were traversing, we went from node 10 to node 20. Then after going to node 30, it went to 40. Then at this place, it looked into the left hand child, right child, which is null. So it returned back and it said that its value does not match and there is nothing further to explore, so it returned null. And since 20 was getting value from one side, so it returned that value, right? That's the easy way to remember, and the logic is quite simple in that way, right? If you arrive at a node which values matches which you're looking for, you return that node then. Otherwise, you go and search into the left and right subtrees. And if you have values coming from both sides, you return that node's value. Otherwise, if you have only one value coming from one side and null from the other, you return the value which you are getting. So in this case, the third example is 50 and 60. From left subtree, it will return a null as expected. From right subtree, it will find the node 50 present at the right child of 10, and as soon as it finds the first value, it's going to return itself as LCA, and so 50 is returned as the LCA here, and that's it. And that's pretty much the algorithm here. So if we see the it's kind of pseudo code here. It's not the perfect code, but the pseudo code matches with the logic which we had written earlier. If you arrive at a node which is null, this is a recursive algorithm. If node is null, you return null from there. If you arrive at a node which values matches with the node you are looking for, you return that node. Otherwise, you go to the left LCA and left and right subtrees, and you traverse those left and right subtrees. And if you find that both of the left and right subtree are not null, both of them are returning value, then you return that node. You do not return the value of left and right subtree, you return that node's value, which is getting the value from both sides. Otherwise, if you arrive at a situation where only one side is returning the value, then you return the not null value. So let's say if left subtree returned the value and right subtree was null, so you return the left LCA. Otherwise, you return the right LCA. And that's pretty much it. This is the this is like 2, 4, 6, 8, 9 lines of code for finding the LCA of two nodes. Now, I have the code in Java in the next as a resource. But before you go and copy the code, first you try to code it yourself. Now you see that the logic is very easy, but it is good and very necessary to write it on your own. That gives you some confidence that you have solved the problem, and it creates a mental structure where logic building will happen flawlessly. So I would suggest you to go to either Visual Studio or Eclipse or any other IDE with the language of your choice, whatever language you want to use, and code this out, run the program and see if you are getting the correct answer. And then you can match with the code I have written and see if both of them matches. Otherwise, go again through the lecture and it will guide you if you are missing something there. So this is the simple algorithm for finding LCA. Now with this, the LCA problem is done. I will see you in the next lecture.